6.4, problem number 4. In a certain article, laser therapy was discussed as a useful alternative to drugs in pain management of chronically ill patients. To measure pain threshold, a machine was used to deliver low voltage direct current to different parts of the body, wrist, neck, and back. The machine measured the current in milliamperes, MA. The pretreatment experimental group in the study had an average threshold pain that was 3.05 with a standard deviation of 1.29. All right, now I just like to write those numbers down because I do. 3.05 and a standard deviation of 1.29. Now what else here? Assume the distribution of threshold pain is symmetric or more or less mound-shaped. All right, so we're making the assumption we've got a distribution of shapes that look like this. So some pain measurements are real low, some are real high, but they follow typically that kind of a shape. Now, part A. Use the empirical rule to estimate a range of milliamps around the mean in which about 68% of the experimental group will have a threshold of pain. Well, I pasted in our empirical rule here, our normal curve with the empirical rule pointed onto it. And if we want 68%, right? 68% here? Well, 68%, that goes from the mean minus a standard deviation to a mean plus a standard deviation. So for part A, I think what we're going to want here in part A, let me get this working. Part A, we're going to have, I want to go the mean minus 1 standard deviation to the mean plus 1 standard deviation. Now, if you want to write ones out there, that's fine. But you're going to get what? What is the mean? The mean is 3.05, and then minus 1 standard deviation, 1.29, to 3.05 plus 1.29. So my calculator shows we're going from 1.76 to 4.34. All right, I guess we're supposed to put these answers up here, right? We're supposed to put them in here. So we're going to go from 1.76 to 4.34. Now part B says, use the empirical rule to estimate the range in which we're going to get 95%. Right now, 95%, follow it down to your picture here. 95% goes where? It goes mu minus 2 sigma, that's what I wrote over here, to mu plus 2 sigma, right? Mu plus 2 sigma. This is going to get us 95%. So if we calculate this, we're going to get 3.05 minus 2 of is times those 1.29s to the mean 3.05 plus 2 of those sigmas, 1.29s. And my calculator shows that on the left, the 3.05 minus 2 standard deviations is a 0.47, and on the right, the mean plus 2 standard deviations is 5.63. So let's put these in here, 0.47 to 5.63.